Hello, everyone. It's great to be here in InfoComm 2024. We are with Samuel Recine, who has been a huge help for us in Brompton with all to do with IPMX, including what 2110 is, and for us to understand what are the benefits that we can get. That at the end, IPMX definitely is that tool that we want to have as LED processing, because the fact is that LEDs never have a normal ratio. They don't follow all these standards. So IPMX is one of these standards that are going to help us give better shows. So this is Samuel Recine. So please.
Thank you very much. I'm happy to be here, Cesar.
So can you tell us a little bit more about yourself and about how you with AIMS and with Matrox are developing these new technologies?
Yes, I'm happy to. Matrox has been supporting many standards for a lot of years, and we have staff in every group that supports the standards. We send people to AMWA for NMOS. We send people to the VSF for the TR10 and the TR03 specifications. We have people on the JTNM team to do testing of systems with 2110 products. We have people that we send to SIMTI and AIMS. I myself am one of the people that attends the AIMS meetings to do education and to have communications about the standards. All of these groups work together to develop the standards, document the standards, release them to the public for free, and do education about what they support.
Yeah, I mean, obviously, it's not only about IPMX. There is so many other things that are so many other standards and so many other bodies deciding how to move these things. And NMOS, AMWA, all these people is just definitely developing and looking at what is going to be the future and how we can improve all these processes. Because video over IP is not new. It has been going for a few years, right?
That's right. That's right. It's early AV over IP was a very good proof of concept, but the standards are there to restore some of the things that we were able to do with baseband that we lost when moving to AV over IP. For example, think of little mini converters, that can go from SDI to HDMI or HDMI to SDI. They were cheap, very reliable, no skills required. So it was a very trivial problem to connect AV signal management equipment to processing equipment to PC equipment. Whatever you needed in an application, a production, you could just convert the signals that you needed and use any equipment that you wanted. So you already had interoperability. Moving to AV over IP, these different product classes migrated differently. Professional processing equipment migrated with things like SIMT 2110 and NDI. AV signal routing equipment migrated to things like Prestron NVX and Dante and SDVOE. And PC equipment uses the blocks that are available in that type of technology. Your tablets, your phones, your PCs have hardware blocks that do H.264 and HEVC media really well. So moving between these asset classes when all of the audio and video is in IP isn't as easy anymore. And that's why the standards are being developed to restore what we were already able to do, but remaining entirely in IP.
I mean, and that's why, as well, many of the systems that you have been describing, they're proprietary. So it complicates things a little bit more as well, because not all the machines can just implement it to have a solution. But do you want to explain us a little bit more of what we are looking at in the slide?
Yeah, this slide is a picture to try to capture the specific benefits of IPMX as an input on an LED wall tile processor or another type of display. So it's the concept of IPMX receivers on displays. And what we show on the left of the image is baseband signals like HDMI or SDI or DisplayPort or HD base T, as well as IP media from different protocols like 2110, IPMX, AES67, and even completely proprietary protocols like NDI. These are all things that could be put on an IPMX network. There are gateways that could allow us to take the baseband media or the IP media from all of these products and protocols and convert them into flows that work on an IPMX network. So you can do, for example, HDMI to IPMX, or uh, you could use an AES67 flow because an IPMX receiver can receive AES67 media. Or if you have a Dante device, you can use the Dante controller to put it into AES67 mode, and this media is compatible. Or if you have an NDI camera, you can convert NDI into IPMX. There are several companies that make NDI to IPMX gateways. So all of these different media are available on the network, on the system, to be ingested into that one IP input on the LED wall processor. Usually, professional displays, such as the processors that you make, will support the highest quality media, the best of the best. So in order to do the best of the best, the lowest latency, the best quality, usually this is an uncompressed IP input. So the flexibility of using any type of source from the best quality sources to feed that input, if that's what you're intending on using, is there. But you also have the ability to use compressed sources that get converted to match your input. So this entire ecosystem of devices and protocols are things that you could use on that single input on your LED tile processor.
Yeah, I mean, this is something very interesting that you have been mentioning before because the first, obviously, we have a few audio devices that can go to your audio receivers just to do either just to output it or to do some sort of to modify the signal somehow. And that's one of the benefits as well of 702110 and IPMX itself is that you are having different streams for each of them, so you don't have to get them in the input, break them down, process your video alone, and then put it back with your audio, synchronize it, and send it out again, right? So there is a few things, and then obviously the whole being able to use compressed and uncompressed in the same system, and then just send it to your devices.
Yeah, this was a feature of SMT 2110 that was preserved with IPMX. The additional specifications that were added to SMT 2110. But in 2110, it matches the SDI philosophy of carrying video and audio and ancillary information as separate flows so that you can manage them and route them separately. So this is preserved in 2110. You could send video to the displays that you want and audio to the speakers that you want. So you could route the different media differently. IPMX keeps that intact with the additional specifications that are layered on 2110.
And there's one of the things that you just mentioned that is using compressed and uncompressed versions of the signal. I guess that you're talking about JPEG XS. Is there any other those sorts of compression?
So SMPTE 2110 supports two things for video. It supports uncompressed video, which is SMPTE 2110-20, and it supports a constant bitrate compressed video. The specification does not specify a codec. So dash 22 says constant bitrate compressed media. And what has become popular with dash 22 is JPEG XS. IPMX keeps that, so dash 20 compatibility and dash 22 compatibility, but IPMX also added with the VSF TR10 specifications the support for variable bitrate codecs, and that opens the door to other mezzanine codec options and also high compression options. So H.264, HEVC, and other mezzanine codecs are also supported by IPMX as well.
And how will we transform this H.264, H.265, or into the IPMX signal, video over IP signal?
Well, IPMX, as far as the NMOS layer for device registration and discovery, that it doesn't matter what the codec is. The transport that is codec independent, and if you need to convert the codec from one thing to the other, you can have IPMX products of one codec and IPMX products of a different codec, and use gateways to convert one media to the other. In fact, you can have gateways that convert not only media but protocols as well. You can do, for example, NDI to IPMX, or you could do uncompressed IPMX to compressed IPMX, or vice versa. These are all options.
Yeah, this is something that you were mentioning before, and I think that it is fascinating that you can just put one of these boxes into your same network. And this is, for me, one of the main benefits of this, right? You can just have one network and escalate it and do changes and apply some new benefits by just connected to the same switch, for example. So you were talking about these boxes that can import NDI and then output. If for us that we are developing a IPMX and 2110 processor, we could just have with one of these network these boxes in the network, we could just have NDI in and IPMX out into our processor.
That's
So
correct. That's correct. In fact, you could even mix networks. If you have an IPMX receiver on your Brompton processor, you could have that on a network with or without PTP. Let's say you want to have mixed synchronization and mixed media. So you could have, let's say, one switch that is configured as a SMPTE 2110 network with SMPTE 2110 media. That switch could be connected to a second switch, which is running with no PTP. So now you could have some asynchronous sources as well. And you could use your content from the synchronized network and bring it into your IP input. You could also bring the asynchronous sources into your IP input. And you could use these gateways to convert media and protocols. So you basically, from your single input, have an astonishing amount of flexibility for what you can bring into the LED wall.
that's incredible. Hey, that's incredible. Do you do we want to continue with what we have in the slide?
Well, the only other elements are IPMX supports all of the timing environments that you can encounter. So as far as PTP, if you have a very, very tight PTP that requires a high fidelity grandmaster and a boundary clock switch, that is supported by an IPMX product. So that type of PTP is no problem. If you're doing something with a lighter type of PTP, like an AES67 network type of PTP with a standard switch, this is also supported by IPMX. And if you have a network that doesn't have synchronization requirements, you just want to have the low latency network with no PTP, this is also supported. Another element of IPMX is the certain things that were optional in SMPTE 2110 were turned into mandatory. So SMPTE 2110 allows you to use um, any media format, but only requires YUV 422 10-bit. Whereas with IPMX, you must, of course, support YUV 422 10-bit for the cameras, but it's also making it a requirement to support the PC content. So non-standard aspect ratios, RGB 444 content, these things are obligatory to support in IPMX products. So IPMX increases the flexibility of the types of media that you can manage on your network. You can use cameras, you could use PC content, you could use any resolution that you want, and of course, any timing.
Yeah. Is there any limitations to the non-standard aspect ratios when you're using IPMX? Because this is one of the questions that a lot of our customers have, and one of the things that a lot of people is looking at is it really that I can just do whatever number of rows or columns I'm sending out? Because obviously we have gone through a strong phase with virtual production, but LEDs in general, they have just the weirdest shapes. I mean, we're in Las Vegas, and you have every building with very long and high LED walls. A virtual production volume is going to be very wide and quite tall. I mean, it's usually a ratio of 50 to 10 or something like this. So, are there any limitations on what people can do?
Any rectangle is supported by the specifications, but to provide a more nuanced and accurate answer, usually it's the equipment that has limitations. Like, for example, an operating system in a computer may have limitations to the aspect ratios that it can support. So there are limits, but not the standards. It's the equipment using the standards that has limitations.
And actually, that brings me to my next question because, as you say, one of the limitations is the computers. Are GPUs evolving in order to align with this type of technologies?
Absolutely. GPUs have more and more media accelerated support in them. So a modern GPU can accelerate AV1, can accelerate H.264, HEVC, and they're adding more to future GPUs. And so creating rich media experiences using GPUs is getting easier and easier because they support so many media formats with hardware acceleration. when you are using a hardware block on a GPU to do video encoding and decoding, the entire GPU is almost entirely still available for graphics processing. It means you're using very, very little of the GPU performance to do the media encoding and decoding. There's a dedicated hardware block supporting the media. So it makes what you can build on an LED wall very rich, very interesting.
That's great. So, is there anything else that you would like to highlight?
No, just very happy to be working with such a nice community of developers, and admire and respect your products.
Thank you very much. I admire and respect as well what you guys are doing in Matrox, and thank you very much for your help.
Thank you.
Thank you.